Hello everyone, welcome to John Matt Classroom. So in this video, we are going to discuss the example for limits and continuity. So kindly refers to the question. A function of f is given as, where we have the function, show in the situation. So find the limit when x approaching 0 from the left for the function fx. Next, find the limits when x approaching 0 from the right for the function fx. And finally, determine the limits when x approaching 0 for the function fx. So what we have to do now is to refer to the function given. So kindly focus on the modulus for x plus 1. So kindly refers to the definition. As we all know, the modulus of x is equals to x, where we have the domain x greater equals to 0, and we have negative x, and the domain is x less than 0. So here we have the definition for the absolute value of x. Next, focus on the modulus x plus 1, where we have the definition x plus 1, comma, x plus 1 greater equals to 0. Next, we have negative bracket x plus 1. And we have x plus 1 less than 0. So kindly simplify the situation, and we will have the modulus for x plus 1 is equals to x plus 1, and we have domain x greater equals to negative 1. Next, we have negative bracket x plus 1 with the domain x less than negative 1. So here we have the definition. So kindly illustrate the situation in a real number line. So kindly focus on the negative 1. Let's say here we have the negative 1. Okay, then followed by the 0. So here we have the situation x greater and equals to negative 1, which is on the right hand side of the negative 1. So the function will be x plus 1. And we have the equal sign with the negative 1, so we are going to use x plus 1 for the function. Next, for the left hand side, where we have x less than negative 1, the function would be negative bracket x plus 1. Next, focus on the 0. So for this case, where we have x less than 0, which is x plus 1. So here we have the function. Next, we have x equals to 0, and the value would be 2. Next, we have the situation x greater than 0. So where we have exponent power of negative 2x. So here we have the situation. So now kindly refers to the real number line. So we have already illustrated the situation in a real number line. So focus on the situation limits when x approaching 0 from the left. So indicate over here from the left. So the function would be x plus 1. So kindly substitute the situation, and we will have approaching 1. Next, focus on the limits when x approaching 0 from the right. So the function would be exponent to the power of negative 2x. So if we substitute the value 0 from the right, e to the power of 0, and we will obtain 1. So in here, limits when x approaching 0 for the function fx, so we will have the value approaching to 1. So that is a situation for the first part of the questions. Next, hence, determine whether the function f is continuous at x is equals to 0. So our focus is on x is equals to 0. By referring to the condition, number 1, f0. So kindly refers to the number line. Here we have f0. If we substitute the 0, so the function will be 2. So in here, the value will be equals to 2. Condition number 2, limits when x approaching 0 from the left and the right for the function fx. So the value is equals to 1. And we can say the limit exists. Condition number 3, must make sure the f0, the value is equals for the limit when x approaching 0 from the left and from the right for the function fx. So in this case, the situation is not equal, because for f0, the value is 2, and for the limit when x approaching 0 from the left and right for the function fx, the value is equals to 1. So as we can see, the value is not the same. So in here, we can say the fx is not continuous, or we can say discontinuous at x is equals to 0. So here we are, and thanks for watching.